Today we'll apply our knowledge of the area of a triangle and algebra in order to solve for missing sides or missing variables within a triangle. To understand the area of a triangle, let's review the anatomy of a triangle. All triangles have three sides, three angles. The altitude of a triangle is the perpendicular distance between the base of a triangle and its opposite angle. That's a very wordy definition, so let's break it down a little bit. When we refer to the base relative to the altitude, the base of a triangle can refer to any three of the sides. This is the side that is perpendicular to the altitude. It makes a 90-degree angle. These are examples of altitudes. Notice they make a 90-degree angle or perpendicular to one of the sides. It then extends straight up to the opposite angle. Think trigonometry. Angles and sides that are opposite each other have special relationships. Here's another example. It makes a 90-degree angle with one of the sides and goes straight to the opposite angle. And yet again, makes a 90-degree angle with one of the sides and goes straight to the opposite angle. In this case, when we have an altitude like this, the base is the side that is 90 degrees to the altitude or perpendicular to the altitude. Be careful, the base is not always the side that's on the bottom of the diagram. Generally, when we talk about the height of a triangle, when we talk about the formula for area, we're looking at the altitude of the triangle, not just the height. Let's talk a little bit about what the area of a triangle means. The area of any closed geometric object is the number of square units that can fit inside of it. So if we have a triangle on a grid like this, we can count out all of the whole square units and then look at the parts. Now this piece is cut. If I take that little chunk and move it up, that gives me one whole square unit. I see that same over here, and up here. So that gives me a total of 4 whole square units together, and then 4 that are broken apart. Units are always squared. This has to do with area. So in this case, if we're just calling these units, it's 8 units squared. It could be 8 centimeters squared, 8 inches squared, depending on the size of each of those individual square units. However, this definition of area has its limitations. For example, if I take a triangle that's not easily recognizable or easy to measure, we can see that there's maybe 2 whole units and then a bunch of little broken up pieces with no way of finding the exact proportions. I can no longer just count my unit squares. Instead, I need to look at a formula. Area equals 1/2 times base times height. So let's look at this triangle here. 3, 4, 5. So I need to take 1/2 of my base times my height. The base in this case is going to be 4. The altitude represents our height. In this case, the altitude looks more like the traditional terminology for height. Our base is on the bottom of the diagram. 3 inches is making a perpendicular line with my base, and it extends directly up to the opposite angle. Now it's just a matter of plugging and chugging. I plugged in what I know, and I can calculate it out. 4 times 1/2 is 2. 2 times 3 is 6. The area of this triangle is 6 inches squared. We can use the same exact formula for unknowns. Let's look at these two triangles. In both cases, we were given the area already, and we were given one of the measurements. On the left, we were given the base. On the right, we were given the height, or the altitude. Let's try to find the height of the triangle on the left, the green triangle. So I'm going to start with my formula, 1/2 base times height. I'm going to plug in what I know. I know that my area is 17.5. I know that my base is 7 because it's the line that's perpendicular to my unknown altitude. And I don't know the height. The height is my unknown altitude. So I'm going to leave height as a variable. I could put it in as h, or I like to use x. Now I just need to use my algebra. 1/2 of 7 is 3.5. It's a one-step equation now. What's happening to my variable? I'm multiplying by 3.5. How do I undo that? I divide by 3.5. That's going to give me 4.86 centimeters. This is the measurement of my altitude, or my height. notice that the unit is no longer squared. We took centimeters squared and then divided it by 7 centimeters. Centimeters squared divided by centimeters gets us back to our original unit of centimeters. Let's try the triangle on the right. It's the same exact process whether I'm given the base or the altitude slash height. I'm going to take my same formula, 1/2 base times height. In this case, my base is unknown. The line that makes a 90-degree angle, or is perpendicular to the altitude, is unknown. It's got a question mark. It could be represented by a variable as well. I do, however, know my height. I know my altitude is 7 yards. This problem already gave us the area, 10.5 yards squared, so I'm going to plug all that in. 10.5 is my area. 1/2 is just 1/2. My unknown is my base, so I can either leave it as b or x. X is a good unknown. And then 7 is the altitude that I already know. I'm going to multiply those two values together. 1/2 times 7 gives me 3.5x. Now it's a one-step equation. What's happening to my variable? I'm multiplying it by 3.5. How do I undo that? I'm going to divide both sides by 3.5. 3.5x divided by 3.5 gives me x, because I get my identity of 1. 10.5 divided by 3.5 equals 3. Again, notice my unit went back to yards from yards squared. That's the value that represents my base. My base is 3, my height or altitude is 7. I could check either of these by plugging it back in. 1/2 times 7 times 4.86 would give me 17.5 centimeters squared. 1/2 times 3 times 7 would give me 10.5 yards squared. On your own, try these three problems. Set up the area formula, plug in the information that's known, and solve for the information that's missing. Be careful with number 3. Number 3 gives us extra information. Make sure that you have the proper base and the proper height or altitude.